Let's start with the first numerical on leveling using the height of instrument method. So the question is that the following readings were taken with a dumpy level with along a chain line at common interval of 15 meters. So every reading is taken along a straight line at interval of 15 meters. The first reading was taken at a chainage of 165 meters, where the reduced level is 98.085. So over here, in the column of chainage, they have added up 15 in every value since the readings are taken at an interval of 15 meters. So this chainage doesn't really matter. This is just for reference and it wouldn't matter in your calculations whatsoever. So the reduced level of the first point, which is at 165 meters chainage is given, it is 98.085, and it is said that the instrument was shifted after the fourth and ninth readings. So the most important part in the question is filling up the table correctly. That means filling it up as in station points, which value of these is backside, which is interside, which is foreside, where was the change point. So that part is the most important one. After that, you can either solve it using the height of the instrument method or you can solve it using the rise and fall method. So first, let's see how to set up the table. So they're saying that the instrument was shifted after the fourth and the ninth reading. So that means that the first four readings were taken in one setting of the instrument, and after that, the fifth, sixth, seventh, eighth, and ninth. Fifth, five readings were taken in the second setting, and the readings remaining were taken in the third setting of the instrument. So that means 3 point starting from here 3.15 up till 0.860. So this is one set of readings. So if these are one set of readings, the first reading was taken at the point of no reduced level, which was the benchmark, where the reduced level was 98.085, and that reading would be called as backside. So the first reading is taken at the first station point, and that becomes your backside. And the last reading in any setting of the apparatus is the foresight. We know that. So this 0.860 would be the foresight, and the remaining two, 2.245 and 1.125, would be intersights. Now this value of 2.245 would be at the second station point, so that would become intersight. The third value at the third station point, that would again become the intersight, and the fourth reading would become the foresight at the fourth station point. Now after that, we change the position of the instrument. That means that when you change the position of the instrument, the next reading is taken at the previous station point. So whenever there is a change point, two readings are taken at that station point. The first one becomes the backside, which is sorry, first one becomes the foresight, since it is the last reading in the first setting of the instrument, and the second one becomes the backside, which is the first reading in the next setting of the instrument. So this 3.125 here is the fifth reading. The sixth, seventh, and eighth reading become the intersight, and the ninth reading becomes the foresight in the second setting of the instrument, and the next reading would be the backside. So these two readings are at the same station point, like we did before. And after that, we took two more readings. So one would be intersight, and the last one would be the foresight. So after the fourth reading, the fifth reading was 3.125, which becomes the backside at the change point. After that, we have couple of intersights at an interval of 15 meters, and then we have a foresight of 1.965, and then we change the instrument. So when we change the instrument, again two readings at the same station point. So station point 8 and station point 4 have two readings each, one foresight and then a backside. So then we have a backside of 1.225, then one intersight of 2.390, and then the last foresight of 3.035. So this is how you set up the table. Now, once you've done that, now we'll have a repetition of how we have proceeded with the height of the instrument method, and then we will also do the rise and fall method. So now the first step in height of the instrument method is that in the first setting of the instrument, you need to find out the height of the instrument. So let's say if I draw these points here, and this is the first point, and this is where I set up my instrument, and the first reading was taken at a benchmark with reduced level known. And when you note down this reading on the same point, that becomes your height of the instrument. So that reading is the backside, 3.150. So in the known reduced level of 98.085, we will add the value of 3.150, and we will get height of the instrument of 101.235. Now when we take the next reading at the second point, you just have to subtract from the reduced level of the line of collimation, which is the height of the instrument, whatever reading you get on the staff. So 101.235 minus 2.245, you get the reduced level of the second point. Now, since for the third point again we aren't changing location of the instrument, so the height of the instrument would remain the same. From the same height of the instrument, subtract the intercept 1.125. So 101.235 minus 1.125, you get the reduced level of the third point, which is 100.110. Now for the fourth point, one reading was taken using the same height of the instrument and same location of the instrument. So we can calculate the reduced level of the fourth point, which would be the benchmark. So from 101.235, we subtract the foreside, not the backside, because since this location has two readings, the foresight was taken in the first setting of the instrument, and backside is taken in the second setting of the instrument. So from this height of the instrument, we subtract the foresight, and we get the reduced level on this point, which is 100.375. So, and we get this by subtracting 0.860 from 101.235. Now we have changed the location of the instrument, and now that we have changed the location of the instrument at the fourth point, right now our instrument location has been changed. So this was the first reading on the same location, which became the foresight, and then the next reading would become the backside on the same location. So now that we have the reduced level of that point, so in that reduced level, we will add the backside, and we will get the new height of the instrument. So now that we have new height of the instrument, we will repeat whatever we did before. For the next 3 points, we will subtract the intercepts from the height of the instrument, and we will get their reduced levels. Now after that, on the eighth station point, so where we took the ninth reading, which was the foresight. So from the same height of the instrument, we will subtract the foresight, and we will get the reduced level of the second change point.